guess we should get started. Do I see Joseph? Is Joseph coming? I haven't seen Joseph. All right, maybe he is busy today, or maybe he's coming. Cool. So, well, first of all, I want to ask everyone. We got 16 people here. I don't know if there are more people coming, but we should get started. I want to ask everyone. Does anyone have any questions or something that they couldn't figure out in terms of running the first interactive pipeline notebook and also the Apache Beam Jupyter notebook on their own? And if you do, please, don't feel embarrassed. We're all here to learn and help each other out. So if you have any questions, I think this is a good time to talk.
Hey, this is Sammy. This is my first class. What would you suggest for me to catch up? I came to know of this only this week.
Yeah, no worries. Hey, Sammy. So I would start with basically just watching the last recording, and if you go into the ML pipelines, are you in the Slack channel? Sammy? I think you're muted.
Oh, sorry, it happened again. So yeah, I'm in the Slack channel and I see it. Thank you. Thank you.
Sure. Yeah, exactly. So that's the it's in the class schedule Google spreadsheet, and the second tab you would be able to see all the Zoom recordings, and of course going forward I'll keep pasting these Zoom recordings with password so everyone can watch it if someone cannot attend the class. Cool. So yeah, I'll start with the first one if you have time, and if you have I don't know what your background is, but if you're not familiar with TFX or TensorFlow, maybe read more about it and study a little bit about it in terms of TensorFlow and TFX, and some basic knowledge about machine learning, obviously. But what I would say is to get most out of this class, it would just be like heavy Python engineering skill. So that's what it is.
Thank you. Yeah, sorry for taking up your time, guys.
Yeah, no worries. Anyone else? Cool. So I assume we all got that going. Okay, so let me, I think today's agenda is basically we want to talk about how to set up a basic Python development environment, in terms of developing perhaps a small package, software package. Then we'll go into reading more about chapter 3. It is a relatively shorter chapter, but I think it's also a very important chapter. Now, what we're going to do going forward is basically diving into each of the step within the pipeline. For this week, it's data ingestion. For next week, I believe it's data validation. Next week, that's data processing or cleaning. And so each of the step will basically drill deeper into each of the components, right? So we got to glance over all the components from the notebook, and we kind of quickly run through them. But we want to understand each of them in a much greater detail on a deeper level, and understand what's going on and be able to apply to your own projects, right? So on that note, I want to get started. So let me start sharing. Okay, let me share my screen. All right, so as you see, I had a black theme, and which I've spent a lot of time customized, but unfortunately, it does not work with these context.run functions with TFX. It wouldn't be able to show clearly the outputs, so I had to change the theme. So this is the class repo, right? So, and we have chapters and components, and the data folder, interactive pipeline, requirements, and so that's that. And I created a folder as a project folder underneath that to kind of just demo it really quick. And that's this one. So now I'm using the older, well, not the older, but like the same virtual environment as the class folder environment, because they're roughly the same. But whenever you get started, you want to try to basically do, let me just clear it, Python 3. And we talked a little bit about this, right? So whenever you start a project, let's assume this is all empty, we would do this. Then we would do source venv being activate. Then you should have this venv activated, right? So then VS Code is great because it will automatically detect your kernel within your venv folder. And as you see right now, it's Dropbox because I'm using Dropbox. So everything is underneath Dropbox. Machine learning ops, building machine learning pipelines, venv being Python. As I said, I'm using the same virtual environment as the class folder, even though this is a project underneath that. Normally, you wouldn't do that. You would, have a separate folder for your project. And of course, you would start another virtual environment for that project. But you want to make sure this matches this. So because it doesn't always match. So you want to make sure this terminal environment, which is underneath this, and this matches. If it does not, you want to enter the path and copy this. And then it will adjust this environment in the right place. Cool. So that's very basic stuff. Cool. So the next thing you want to do is you want to make sure, you want to have, let's go through the project folder structure. So you want to have a requirements.txt, that's very obvious, which lists all the libraries and that we would need, okay? And also you want to have a git ignore file, and to create a file is basically touch and code. If I want to create test.py, that would just be test.py, and if I save it, it would just save under test.py under the direct root the root directory. So, and I don't know if you guys know this, but so in order to have this code command, you need to export the VS Code's path, which is a pretty handy command. So if you haven't done that, just by typing in code wouldn't work, okay? And so touch is just basically create a file. Code is basically opening it up. So touch and code would just be create a file and open it up. Fairly straightforward. Also, you want to have a readme.md. I'm going to commit all this, try to commit all this into a public repo so everyone can play around with this if you need to. Of course, that's just basically, you have a markdown file, and you can start with basically, tell people what you want to create, and that would, every major repo and probably every repo should have a readme.md, and you should try to kind of explain, what's going on with the project, and potentially, I think it's a good practice to explain the workflow as well. So in this example, I have this project called Consumer Complaint because the data set is consumer complaints. As you probably recall from last class, we downloaded this 76 megabytes data set from Consumer Bureau, Financial Bureau, and which basically is a data set that's about consumer complaints for financial products or services. And what you want to have is several modules and also several folders. So you want to have a config folder. So everything in the config is where you set all the directories and all the credential path. So what you don't want to have is try to have these directories and paths within the .py file. In that way, you can have a one place for that. It's just cleaner, and also it's a better practice. And also you don't have to constantly change. If this exists in multiple files, then if this changes, then you have to change multiple places. If you just put it under one file, then you only need to change one place. It's just easier. Okay, and you want to have, depending on the project, you want to have a file, and this is where I've put the data. And of course, you want to try to ignore that. Don't commit your data or any. I try not to commit any CSV files to GitHub. And this is where you store your SQL commands or language execution code. Yeah, so that's all stored kind of within one place. Where I store the credentials is I kind of stored it outside of that folder, depending on what people like. It's just a preference, I guess. And of course, you want to ignore that, and you would see everything that's ignored is gray, and everything is being tracked is not gray. And if you have this extension source control, you will see what I have changed and what I have not, and you can directly commit here or command in the terminal, whatever you want to do. But it is easier. You can just press plus and type in a message, then press this button, then it will just be a commit. It wouldn't push it for to to the repo for you. You would have to push it for yourself. And going back to the directory, so this is where I store the credentials. This is something I had to use because I wanted to try out Bigquery, so directly ingest data from Bigquery. So I had to have a Google Cloud Computing, GCP's service account open on that. So that's the credential I saved. And of course, practice example. This is just something that I'm storing here for this class purposes. But if I need to develop more, I would develop, this probably where I would put, and I named it consumer complaint classifier. This is basically where I would store, anything ML related code. I would just put it here. And I did have another folder called data connectors. This is where I just built a quick connection to Bigquery using Python. And what's also very interesting is I found out, hey, pandas, also has a function that you could just directly read from Bigquery. It's called gbq.read gbq. So from pandas.io, import gbq and gbq.read gbq. You would it's a separate library, but underneath pandas that you would have to just install it separately, but it's under pandas. And data connectors where I usually store a bunch of data connections. Maybe it could be S3 buckets, could be Google BigQuery, it could be, I don't know, something else. It could be Google Sheets, it could be Google Analytics, bunch of connectors that you want to build. And typically it would consist of, bunch of classes or one class if it's easier, if it's just a MySQL connection or a database connection. And what you want to do is also you want to have this init.py. In that way, it allows you to kind of do the imports without problems. And we talked a little bit about setup.py, and this is where you want to set up your package. Okay, and as you see, I have this named consumer complaints. So that's the package name. What's the description? This is the classifier to classify consumer complaints. So I just put it in very quickly. My email, the authors of this package, and requires Python large greater or equal to 3.7.0. And you want to kind of define, you want to make sure you have the requirements.txt. So once you have that, you don't necessarily need to do pip install this anymore. You are actually, if you're going with local, so if I delete this, you can just pip install -e and dot. That means it will just install the package, which will also install all the libraries in the requirements.txt as well. Since I've already installed it, oops, what's the error? Oh, I think I had something, for some reasons I had this one. Okay, you see requirements already satisfied on everything. Then it will regenerate this info. And let's talk quickly about this. Nothing in this one. Package info. This is where you have the package info. So as you see, I have the version. So whenever you develop a package, you want to have a version number, and typically you start with 0.1.0, and this is similar to Python, right? So Python could have 3.8.4, which is what I'm using, and this is how every package gets developed. This is kind of a small update, and this is more major update, and this is usually not compatible. So Python 3 is not compatible with Python 2. So this is like the major version, major version, basically. This is kind of a major update, and this is kind of a small update or fix.
When Chen, where
Yeah.
was that you put in the your configuration for the files that's in package info? Where did you set that? That when you called and ran pip, okay, that isn't set up in. Okay, got it.
Yeah,
There, that's it.
right here.
That's it. That's what I meant.
Yeah, exactly. So this is where it is, and also you want to have this package data as your package name and version, and also you want to specify, hey, is your package running? Is your package compatible with Python 3.5 or Python 2 or Python 3? So for me, I just put it larger or equal to 3.7.0 because I'm using 3.8. Does it mean it cannot run on 3.6? It probably can still run, but it might run into trouble. I don't know. 3.6 does have some features. 3.7 or starting from 3.6, it does have features that 3.5, a lot of times you would run into trouble with 3.5 at least. So a lot of times, 3.6 is probably the least or the latest version you at least want to have. Cool. And package info, homepage unknown. I didn't put the license info. This is description. And yeah, requires, see, it will just list all the requirements, required packages, sources. So yes, this will give you all the sources, nothing on top level.txt. So this is kind of, whenever you install this setup.py, it will generate this info. Of course, you also want to ignore that. So that's where it gets get ignored. Now, the other benefit that I said is basically you can do absolute imports. So now basically I can just do consumer complaint.config import config. And I don't know if I have something here. Yes. So everything would start flowing from consumer complaints down to every single folder. And whenever you need to, import something, it's just consumer complaints. Dot, it could be, I don't know, data connectors. If I want to import this file, it would just be consumer complaint.dataconnectors.google Bigquery. Imports Bigquery connection. So that's how you import everything. It will just all start from this. Yeah. Someone want to say something? Sorry? Okay, no? All right. So if I want to import something from consumer complaint classifier, it would just be classifier dot some one, a package imports a class. As an example, I don't have anything underneath that right now, but that's just how you import everything. And it's just clear because now everything starts flowing from that, and this is a folder, this is a folder, and this is a specific file, and this is a specific class within one file. And in that way, you don't have to do relative imports, which if you move a file from one folder to another folder, it will just mess up everything. If you use this, as long as this file exists within this entire project folder, it's the same exact import path. So, which makes things way much easier. But what you do want to do is pip install again. This is for local development. Now, if you, let's say, if you are trying to deploy a Docker container, what you want to do is run pip install. That's it. And it will just install this setup.py. So instead of pip install just do setup pip install dot. So we just dot means the current directory, and setup.py is within the same directory as Docker file. Okay. Anyone has any questions on this?
I'm sorry, what does pip install have to do with Docker? Confused.
Oh, basically, whenever you if you are building an image, you want to install everything, right? You want to install your package, install all the libraries, because where you're deploying to.
Oh, no, I'm sorry. You just did a run command within the Docker file. I understand. You're showing how to use the pip install within the Docker file. I got it. I just missed the context.
Yeah,
Thanks.
no worries. Yeah.
Yep.
Cool. Anyone else? Cool. So one last note, I guess, if you're like me, again, who are using VS Code and who likes to test codes, and this is a very great magic command that you can test your codes running on the site. And if I do this, it will just be interactively executed from the site. Okay, so as you see, it ran through, and it will be able to show everything on this end. Now, you do want to try to see, hey, is this shell executing within the virtual environments? So to make sure we're doing this correctly, yes. So we are within the same virtual environment. That's great. And this is just like a Jupyter notebook, except it's not within a .py file. It's not within an IPyMB file. It's within the .py file. And it makes the development environment much cleaner, because you can do all the testing code here and all the development code here. So whenever you're done with testing here, you just write your code right here. Instead of exporting it from Jupyter Notebook and everything, it's much harder and inconvenient. So, and once you are done with, you're done with your development, what you want to do is, I set basically a shortcut. What you want to do is change all occurrences and just delete it, and then it will just be your .py file again. But you
That's
don't
cool,
have
man. Now I understand that. So it's really just that %% in
Yeah.
VS Code that allows you to treat it like that. That's
Exactly.
pretty cool. Yeah.
Yeah,
like
exactly. And you don't even have to delete it, actually. If you don't want to, it would be treated as a comment. So this would have no problem of running through the entire script even if you don't delete this. So yeah, that's FYI. Cool. That's it in terms of the rundown of developing a package. And pretty much that's how I do my work nowadays. And then I just develop a Docker file, and if I need to, deploy it on AWS, ECS, I just push the Docker image to ECR, then then spin up a container on ECS. So that's pretty much it. Cool. So if no one has other questions, we'll dive into the reading for today. It will be on chapter 3, data ingestion. And hopefully we can finish it in 45 minutes. Maybe let's make it 45 minutes till 5 minutes to 11, I guess, p.m. EST, and 5 minutes to 8 o'clock PST.
Oh, sorry, what are we reading?
The chapter 3, data ingestion.
Okay.
Yeah. Thank you, Mash. Okay, I think the screen froze. I think time should be up.
Oops, sorry about that.
No worries, Nash. Thank you for the timer. How's everyone doing with reading? Is everyone done? Should I assume everyone's done with the reading?
Let's take the silence as acknowledgement and continue.
Cool. All right. Okay, so I just pushed this repo up. And this is basically my code in the package format under this consumer complaint project. And obviously, you still need to create, maybe I'll edit this readme.md a little bit, but you still need to create the venv. Make sure you do the pip install -e dot, then it will install the packages for you. And so on and so forth. So, of course, I have this practice example that we'll go through. So I basically took the lecture's code, but I think I did some revisions. If you had some trouble running through this the lecture's code, you shouldn't have trouble running through this code, as I've tried to debug it. And of course, adds some more stuff such as Bigquery, which is cool. Because normally you wouldn't run this from your local data files. It would just be running from a database, such as Bigquery. Okay, so let me post this. And I will also post in the chat as well. Okay. By the way, it was not very easy to debug this Bigquery thing. It took me a while today, and there was not much.
On it since afternoon.
Yeah, there was not much documentation for this, and there's not much documentation for TFX. Well, actually, it does have documentation, but it doesn't have. It's not like if you're Googling, questions for or error messages for like pandas or Python. You know what I'm saying? Like, if you're trying to debug a TFX problem, you're probably not going to get an answer from Stack Overflow. Most likely not a full answer. You would have to dig around a bit, look into the documentation stuff. So, okay. That being said, let's start chapter 3, data ingestion. So data ingestion is basically the first component of this ML pipelines. And we kind of run through a quick rundown of the entire pipeline, but that is the first component. And following that is data validation, data pre-processing, model training, model analysis, and validation, model deployment. And concepts for data ingestion. I think this is quite important to remember. TensorFlow has its own data structure to store data and represent data. And it's called TF records. So TF record is a lightweight format optimized for streaming large data sets, while in practice, most TensorFlow users store serialized example protocol buffers in TF record files. The TF record format actually supports any binary data as shown in the following. And TF record files contain tf.example records. So the difference between tf.example and tf record is that tf.example is just basically rows, data structure representing every data row within tf record. That's kind of the difference. And tf.example as data as rows within the TF record is also the default data structure within the TensorFlow ecosystem. So you might see this, in TensorFlow TF as well. So in TF record is also optimized for downloading or writing large amounts of data quickly. Okay, so there's a reason why they developed that. It's because for efficient data processing and training probably as well. The data structure is system independent since it relies on protocol buffers, a cross-platform, cross-language library to serialize data. And so that's kind of the data structure we're dealing with, in terms of TFX. We're not using, we're not doing PD read CSV. You see what I'm saying? Like we're not like directly using, CSV files like pandas. We would have to convert data structures into TF records so that it can be better processed. Cool. So the process of ingesting, splitting, and converting the data sets is performed by the example gen component, as we see in the following examples. And data sets can be read from local and remote folders, as well as requested from data services like Google Cloud BigQuery. And here's a code example of ingesting local data files. Okay, and hopefully at this point you guys have already downloaded the data set and store that within the folder called data, as that should be the case. And you should be able to run this cell without problem. And it will output something like this. Okay, and basically it's the metadata of the run, and the outputs of the components are shown below, highlighting the storage locations of the training and the evaluation data sets. Okay. Now, yes, so you want to make sure the input path of example gen only contains the data files. The component tries to consume all existing files within the path level. Any additional files can be consumed by the component and make the component step fail. The component is also not stepping through existing subdirectories unless it's configured as an input pattern. So make sure, and that's what I did, within the class folder, my data root only has one file. Okay, so if you store a bunch of files in it that has nothing to do with data, that CSV example gen would return an error. Okay, so if you are encountering that error, make sure you check, you don't have other files stored underneath this folder. And I'm calling it data root, but under the if you just directly clone this and run the commands to download the data, it would just be called data. Cool. Any questions on this? Okay. And also, you can import existing TF record files. Okay. So let's say you have the TF record files already existing, then you can just use import example gen. That's pretty, so that's different from CSV example gen because it's a different format. It's in TF record format. Converting Parquet serialized data to tf.example. That's using file-based example gen in a similar way, but in Parquet formats. The different formats of data files. I'm not going to go too deep on that. Converting your custom data to TF record data structures. So this is what I want to kind of touch upon a little deeper. So let's say you don't have a CSV format, then you do want to convert everything into TF record, right? But I think he give out the authors give out example in CSV. So, but I think it's probably good to make sure you're having the right data type for every single column. Now, I do see a problem of this because what if this data table has like 100 columns or 300 columns? Then this does become a very cumbersome task. But I guess sometimes it's just not avoidable because you do want to make sure every data type is, regulated and checked. So, but if you guys have had experience of dealing with, large number of columns of data sets and how you can check them or regulate them in a more efficient way, please let me know. I'd love to learn. Okay.
Hi. We
Go
can
ahead.
use Rapids as an alternative to have those columns, those large data sets that can be transferred to GPU. And I've used that with Spark once or twice in one of my previous projects, but yeah, that's a completely different pipeline as compared to the pipeline and the stuff that and the workflow that we have here. So the data ingestion component here, it's totally related to everything is currently being performed on the CPUs. There, I had to use that plugin to transfer those large batches via Rapids to the backend, and then do my compute there, and then the similar downstream tasks that are then in getting your stats with respect to the uh, predictions that you want to make. So that's one way, but yeah, I don't know how they can do it here, but yeah, if I find it, I will share it with you guys.
Great. Thank you. Cool. So I'll definitely check that out to see how I can do it better under Rapids. Cool. So in here, it kind of gives a quick example of what tf.example looks like. It's more like a key value mapping data structure. So I guess it's more like dictionaries. I don't know if it's exactly dictionaries, but it seems like it's like a dictionary. And in the case of TF record data structure, a tf.example expects a tf.features object, which accepts a dictionary of features containing key value pairs. The key is always a string identifier representing the feature column, which is this column A, column B, column C, and the value is the tf.train.feature object. So such as this, that's kind of what a TF record data structure looks like, and it's a record 1. TF.trim.feature allows 3 data types, bytes, floats, and integer 64. Okay. I don't know if it allows TF.integer 32. That would be nice, because I guess that would save, some memory. Half will cut in half. Am I nuts? I would have to double check. And this is a way to kind of basically, convert your data types. And so this is sort of, if you're familiar with pandas, then it's sort of like as type function to convert your column data types. Now, and we're basically just calling these functions in every single row, and basically it loops through every single row. So when you open that file, use a csv.dict reader, and you loop through that row, and you pass every row into the tf.trim.example function. And while you do that, you're passing every single function, helper function, to convert the data type, making sure everything is following the exact data type that you want. Then you write that to this file called consumer complaints TF records. And of course, if you want to change the file path, you should change this, right? And that's what I did. I wanted to set my own path, and I defined it in the config. So I called it record file path. So I basically defined it here. So I didn't just let it store, in my directory. So
can I ask something? So you have to be familiar with the data set, because what's happening over here, the section 2, it's not only going row by row for every column. For every column, for every feature in the data set, in that row, you have product, and you know that for product, you're going to do a bytes feature, subproduct bytes feature, and so on. Zip code is an int 64. And what was the other one? There was a third type that you had defined above. Yeah. So bytes feature, float feature, feature. And so there's nothing for float feature here. Oh no, there is. Zip code is int 64 of a float, but it's not using floats feature.
Correct, because it just wants to use integer. Yeah, zip codes, obviously zip codes shouldn't have like decimal points. So
this still requires, all this is doing is just making sure that the type of data that we're ingesting is what we want it to be. So we still have to be very familiar with our data set.
Exactly, because going back to this, remember, you're already done with the EDA. This is the third phase, right? You're building the pipeline in the third phase. You're not doing this here. You're not doing this here. So you should already be familiar with your data set at the third phase. If that makes sense. Yeah. So exactly. So you should be familiar with your data sets. But of course, we're directly jumping into this class, right? As the phase 3 of the entire project's life cycle, then of course you need to do your own homework. We all need to do our own homework to understand the data set. But let me just run through this since I basically used pandas to read through that. So let me just do that really quick. Okay, so I have a complaints DF, right? And this is a good way to show you guys how this works. Complain df.info. So you see, if I use pandas to read it in, it's object, 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 zip code, and this is integer. But look at what the authors want to, how they want it claim the data types. It's pretty much just bytes. And bytes are, I guess, just if you're using strings, you're using bytes, integers for zip codes. But notice they want bytes or strings for consumer disputed. So that's not how the CSV file is currently structured. So they're changing the data types, right? And if we quickly look into one row of data, so this is a quick way of kind of letting you glance over all the information for one row. So row 0, index 0. Debt collection subproduct, I do not know. Issue disclosure verification of debts. Sub-issue right to dispute notice not received. Consumer complaints narratives. I was denied employment because of blah, blah, blah. Company Encore Capital Group. Okay. I was never noticed of any hearing, received notice of collection of debt by Midland LLC. So I guess, one consumer is complaining, hey, he or she was received a notice of collection of debts, and he or she did not receive any hearing or documents and stuff. And this person is based in New York State, zip code 113. They anonymized the last 2 digits of zip codes. Company response closed with explanation. Timely response, yes. Consumer dispute is 0. Okay, so I think 0 is okay, but if you do dispute, then it's 1. I believe that's what it is. Okay, and let's look at, to see if there are nulls. Okay, so we don't have nulls or NaNs for our target label, which is good. We have a bunch of subproduct NaNs, sub-issue NaNs, not much of state and zip codes, which is fine, I guess. So it's relatively okay, except 2 columns, subproduct and sub-issue. Okay. Any questions? So someone asked, DPy asked, does that tf.feature handle missing value? I believe there's a way to do that, but I don't think they're doing it here. And right now we're just data ingesting it. We're just ingesting data. So we're not, I don't think we're even handling missing values. That will be in data pre-processing chapter. So 2 weeks from today, I believe we'll be talking more about that. This is just ingesting files into the tf.record format.
That's a transform library, and it has that feature. Let me try to find the link and paste it in the chat.
Right. Awesome. Cool. So anyone had trouble running through this? Because I had trouble, and I had to use encode UTF-8. So anyone had trouble running through this script? So basically, this is under chapters. So under the chapters folder within the class folder and under data ingestions, so convert data to TF records. This is the original file and script from the book. Anyone had trouble running through this?
Yeah, I had the same trouble, but if you specify the encoding while opening the file,
Yeah.
that should be enough. So
Yeah, exactly. So if you have, so you're saying basically this could be enough.
yes, we don't need to encode every feature.
Great. Okay. Good to know. I didn't realize that. Okay, so if you do have trouble running through the class code right here, make sure you encode it with UTF-8 right here. I did it throughout. That was probably not necessary. I'll double check. Okay. And once you do that, you should be able to see a TF records file. It's about, yes, it's about 95 megabytes. I don't know why it's larger, but perhaps it can be processed more efficiently this way. It's supposed to, I thought it's supposed to be smaller. I can be wrong on this, but this is what it looks like. Okay, and I saved it under record roots. Okay, back to the book. Okay, you could also ingest the remote data files with S3 or Google Cloud Storage. And so this is very cool. But here's a but. But what's but is they don't allow you to directly ingest data from, like AWS RDS. You would have to convert them into a CSV file, then do that. So this is something that's very much not, not cool. And so you can only do it from Bigquery. So that means you would have to use Bigquery as your database if you want to ingest directly from databases. But also you have a choice of open source database such as Presto. I have not used Presto previously ever before. I've always been using AWS RDS for SQL capacity, and just, it's cheap, it's easy, and it's MySQL based. And but I had to, start using Bigquery because of this. I guess that's the purpose of doing this, is to get everyone on board to Bigquery. Great. Okay, and also notice this is already deprecated or about to be deprecated. You should start using input base. Input base, and just directly a string. That's the latest way. So the book, again, the reproducibility of this book is not as high as it should be, but we're all here to help each other out. So, okay. So Google Cloud Bigquery, that is, something very interesting, because we all want to try to ingest data directly from a database, right? And if we have to use Bigquery, that's fine. And but we should be able to know how to do it. Now, the book does explain how to do it. So first of all, you want to store your credential underneath environments. And of course, I'm sure you can pass it in somewhere. I'm not sure which function it is, but I just did it with the environment, os.environ, and path to the credential file, JSON. And the way how you do this is you want to try to basically go to Google Cloud Platform. I'm just demoing this very quickly in case someone's interested in this. So I just created consumer complaint project. This is how you create a new project. You press this button and you create a new project called consumer complaints. Okay. And the way how you create a credential is through IAM admin. And there's something that's called service accounts. If you're familiar with Google platform, you will have experience with this. Basically, you just have to press this button, create service account, fill out the form, tell GCP your account name, and it will just be like, it will just fill it out for you, right? And fill in some description. Then you can just press done pretty much. Of course, you want to grant this account access. I just say like all access, but in a bigger company, you probably want to be more careful in terms of what access you want to grant to a specific service account. And there's a specific, access you can grant in terms of Bigquery or a specific product. Okay, once you do that, then you basically are on this page. You have that created, and you want to manage keys. And I'm showing my key here, but I would have to delete it down the road because this is being published. And what you want to do is add key and create new key. Okay, then it will download this JSON file for you, which I stored it under credentials and renamed it under credentials. And this is the path. The path to that file is where you want to pass into this os.environ and you want to name it exactly as Google application credentials. Okay, and this is just the path that I imported in. So once you set that in, you should be able to run Google BigQuery. But notice, so when you run context.run this, it would have trouble. Now I had to like debug this. It took me a while to figure out what to pass into this. And even some of the, I think, tutorials, and the book did not mention this. So you will see the book just pretty much stopped at this line of code. And if you run this, pass this in directly to the context.run, it wouldn't run. You would have to pass in these two arguments as well. What you want to do is, well, first of all, you need to have a database, right? So you need to create a BigQuery database. And so that's what I had to do first. And this is what I create. And it would also create some temporary data sets, which I feel like it's probably not necessary. There's probably a better way to do it, but okay. This is a consumer. Yeah, go ahead.
Yep. Can we import this CSV to a particular data set here?
You mean, yes. So you can, and that's kind of what I did. So you don't have to, again, you can just, sometimes you can directly upload and, but I like to do it from a pandas level. And so sometimes I just basically, what I did was, let's see, I basically just read it in as a pandas data frame and 2 GBQ. GBQ is just Google BigQuery. And specifying the destination table and your project ID, and if it exists, replace. That will create a data table underneath your BigQuery panel or database. And this is your project ID. So if you go into, this is where you find your project ID. Don't use project name, because project name wouldn't be correct. Project ID is the correct one. Okay. BigQuery, back to BigQuery. And BigQuery, just like any SQL, you can just write pretty much SQL-like language. Maybe there's some minor differences, but it's pretty much the same. And yeah, if you run this, so there's a sheet for you. This is something that RDS probably doesn't have. I haven't seen that. And what's also cool about BigQuery is that it has public data sets. So it has lots of public data sets that are publicly available to everyone. And some of them are quite interesting. And I think, you know, if you're interested in that, there it is. Tons of data sets, right? Even COVID-19 data sets are all public and free. So I don't know why this is taking so long, but it doesn't matter. Okay, and now if you recall, everything is run on Beam, Apache Beam. So this is, you will get errors if you don't pass in these 2 arguments. That's why you gotta pass in Beam pipeline args. Okay, so I'm gonna run through these 2. Okay, so references to pipeline option would not be supported. And does not exist. So we'll create it as temporary with location equals to US. And this is where I had to create a temporary location, and somehow it generates temp data sets. I would have to find out a way to avoid this, because this doesn't seem to be the best way to do this. But this ran through. If you don't pass in these 2 arguments, it wouldn't. Okay, but then, you know, in this way you can directly ingest from BigQuery database, which is cool. The book also mentions the way how you can split your data. So before you even pass into CSV example gen, you can split the data set in train, eval, test, and the book just used 6-2. So 60% train, 20% eval, 20% test. Okay, if it's existing data set, then you just use this function. And span data split allows you to kind of create snapshots of data, which replicate existing data records. So cool. And one last example. I know we're running out of time. I don't think it gives out NLP example, but it does give you the example for images, ingesting images. So we've been only talking about structured data, right? And this is unstructured data. The way how you do it is basically use tf.io.read file. So every image path will be passed into that, and it will become a variable called raw file. And if it's not found, it will return an error, but it will continue. And then features equals to tf.train.features feature equal to this. And you can then pass into bytes features. So, and you have to numpy it first. And general label from that. So it's actually relatively simpler because, you know, pixels are features of image rather than columns compared to structured data. So it's relatively more straightforward. Cool. That's pretty much it. And again, I would suggest you to play around with this, especially the BigQuery. But you have to create the BigQuery first, create a table first, and also you would have to have a Google Cloud Storage to passing as a temporary location. So I had to create this in order to let it go through, but seems like every temp file has been passed through to the BigQuery. So this is where the temp location is, and you had to set it as a Google Cloud Storage location. Again, I don't know much about the reason behind this, why that we have to do this as a temporary location, and I would have to dig into this more to find out how I can do this better.
Very good. I can imagine there are a couple of questions, even in my mind. I'm getting this question because I've been burned by this, but not so much on GCP. Can you go to your billing and check for all of these services that you've spun off, what is the expected charges? And you didn't do a virtual machine. You're just doing storage and BigQuery, which aren't very. So average monthly anticipated is in the few cents.
Yeah, just few cents, not much.
Mm-hmm.
Yeah, that's my billing account.
Yeah, and that's it. That's just mine.
Okay, cool. Yeah, I mean, these things don't cost much at all. And plus, that was just, what, 80 megabytes of data stored for like half a day. Yeah, shouldn't incur too much cost. But yeah, I mean, if you don't want to spend any money, then obviously don't spin up anything. So.
I think it's my personal sense, and having made the choice that, you know, I am not going to get my own GPU-based machine or anything of the sort. Just stick to the cloud, keep it serverless. Honestly, you're still winning by going serverless.
Yeah, exactly. Because for many companies, people, I think server administrator, unless you're really big and you have so many servers to manage, then it makes sense to hire server administrators. But for smaller companies, it's just good to keep it lean and neat. So
I would add to that modern day companies, the startups that are digital first, that are AI first and data first and all that, they're serverless right from the start, right from inception.
Yeah, exactly. Serverless architecture, serverless plus container. That's absolutely the way to go.
Yep, totally agree.
Yeah. So, yeah, again, I'm trying to get better with Docker as well. Yeah. But I think one note is a lot of these vendors are getting off of Docker. I think they're, especially AWS, that's what I've run into. One of the issues is that in some, I think 6 or 12 months later, they will no longer support Docker. I don't know if it's complete, deplatforming, and I don't know the rationale behind it, but they're going to support containers. This is what many vendors will support after they drop Docker support. So
it will be the same with all the major cloud platforms, or just with AWS?
AWS drops Docker support. Support. Hold on. Major vendors drop Docker support. Something like that. Kubernetes is removing. So yeah, Kubernetes is certainly removing. But I've run into, so ECS, I believe AWS ECS platform 1.4 not supporting Docker. Okay, that was one of the issues that I ran into. The platform 1.4 of the Fargate, it was a Fargate platform. It just it had trouble with Docker, and the latest platform, yeah. So serverless containers, yeah. It might not be a total drop on Docker, but Kubernetes is certainly removing Docker support, which is huge. Yeah, I mean, considering Kubernetes is pretty much just container management orchestration tool, and Docker is the major, container vendor out there. So user will still be able to use Docker containers, images, as well as create containers that look identical at runtime. Yeah.
So they are replacing it with container D, right?
Yeah, container D. Yeah, container D.
So we will have to learn another. Okay.
Yeah, exactly. I would suspect it will be relatively similar, because Docker didn't invent container technology. I looked into the history. And the container technology is actually not as new as people might have thought, but Docker also didn't just invent it. They might have made it way much better, but they certainly didn't invent it.
Yeah, wasn't it Red Hat that invented it?
Container history.
I think it was with virtualization and stuff. The container on the servers and the
Nope,
virtual.
Yeah, I just saw Solaris on.
It's almost as old as VMs.
Yeah.
Yeah. So Docker is not, container technology is not as new. So, but it's super cool. I absolutely love it. And right now, AWS Lambda also supports container. So you would have serverless and container and just a function. So if you only have a function and you don't want a server, and you can also just deploy it on AWS Lambda if it's an easy one. So literally you don't even need, you know, if it's literally just a function, you can just use Lambda container. This just came out late, end of 2020. So yeah.
Yeah, this is why everybody is talking about Lambda containers with respect to the serverless.
Yeah, absolutely. Absolutely. Cool. But Lambda does have runtime limit. So that's a constraint. So if you do run into a runtime limit, then which is 15 minutes, then you need to use ECS with Fargate. All right. On that note, I want to thank everyone for joining this session. I really appreciate it. I know we talked a lot about different stuff and also how to develop a Python package and stuff. So bunch of exciting, great stuff. And hopefully everyone will still continue to participate in the future lectures and classes. And yeah, thank you everyone again. Have a good night.
Once again,
Good night, guys.
Yep. And folks, if somebody else can also sign up for next week's session or the week after, I think the week after we're going to do a practical, but for one of the chapter sessions, it'd be awesome. Let's not have Wencheng do all the hard work here.
Thank you, Mesh. Thank you. All right.
Yeah.
Talk to you guys next week. Thank you. Bye-bye.
Bye. Good night.
Thanks, guys. Take care.